What is going on, everybody? Back for another video. This video is the definite integral. So it's going to be similar to the video right before this one, the area under the curve. We'll use a little bit different notation now, and this is the notation you'll use going forward. But you can see here we've got the integral f of x dx, and we have limits on the integral. We've got from a to b, and that is equal to capital F of b minus capital F of a. In other words, we integrate and then we evaluate the antiderivative at b and a and subtract the two. So let's go ahead and get started. All right, so they want us to evaluate the integral x to the fourth dx from 0 to 2. All right, so let's go ahead and do that. Let me change colors. So we're going to get 1/5 x to the fifth, right? We add 1 to the exponent and then multiply by the reciprocal of the new exponent, and that's going to go from 0 to 2. Okay, so in this first problem here, let's just talk a little bit about the plus c. I explained it in the last video, but I'm going to explain it again. Now, remember when we did the indefinite integral, you would do this as x to the fifth plus c, right? You always add that constant term. And we're actually doing that here, but we're doing some stuff in our head, and the plus and the c is going away. So let's just go ahead first and work this problem, and then I'm going to come back with the plus c and show you what happens to it. Okay, but yes, if you're thinking about where's that plus c, yeah, it's there, but I'm going to show you why we don't write it after we work this problem. All right. So now we've got to evaluate this. Now let's talk about this. Notice we've got the 1/5 times x to the fifth. Now, if you're taking notes, don't write this down just yet. So that would be 1/5 times 2 to the fifth minus 1/5 times 0 to the fifth. All right, and that's perfectly fine doing that. But let me show you something that will make it a little bit easier to evaluate this. And like I said, you can write it out like this, but what I like to do when I have like the 1/5 and then I've just got this single term here, I like to do the 1/5 and then times 2 to the fifth minus 0 to the fifth. So it's, see, what I had written before was this right here. You see that? That's what I wrote a while ago. And look, all you're doing is like you're bringing that 1/5 out. Okay? And to me, this is easier to evaluate than this. Now, I understand on this problem it doesn't make that big of a difference because this goes to 0 and you just got this part. But, you know, what about when that's not a 0? You see what I'm talking about? So, to me, when you have a single term like this, to me, I think you just leave this coefficient out here and then plug the 2 and the 0, your limits in. It just makes it easier to evaluate. Okay, either way is correct. This one's just a little bit easier. And so this would give us 32/5. All right. So that's not too bad. All right. Now, let's look at this. Let's talk about what happens to that constant c. So let's just come down here. We'll do it in a different color. So yeah, typically when you integrate, you've always been told add that plus c, and that's right. You know, you add the plus c. But let me show you why we don't put it here. So we got 1/5 times 2 to the fifth, right? We're evaluating now, plus c minus, okay, so I plug the 2 in. Now let's plug the 0 in. So I got 1/5 times 0 to the fifth plus c. Now, look what happens here. Do you see how this is c and then minus? You see the minus c? What is c minus c? See, after we distribute that negative, we got c minus c. That goes to 0. And that's what happens every time. The c, the constant, is going to go to 0. So what we're doing is when we integrate this, yes, we're putting plus c, but then we're doing that in our head saying, okay, c minus c is 0, so I'm just not going to put it. Okay, so that's the deal with that. Okay. All right, let's go to the next problem. All right, so we've got the integral 1 to 3, x to the negative 2 minus 1 dx. All right, so let's integrate. So I've got x to the negative 1. We add 1 to the exponent, right? So that's negative 1. And then multiply by the reciprocal of your new exponent. And then minus, and then the antiderivative of 1 is x, and that's going from 1 to 3. All right. So before we evaluate this, let's clean it up a little bit. So this is going to be negative 1 over x. See, there's the negative out here, and then this x to the negative 1, putting it in the denominator. And remember, when you move something across the fraction bar, it changes the sign of the exponent. So it changes from a negative 1 to a positive 1. Minus x, and that's going from 1 to 3. All right, so now we need to evaluate. And so that's going to be negative 1 over 3 minus 3 minus, and now we plug the 1 in, negative 1 over 1 minus 1. And when you punch all of that, I guess you could punch it all into your calculator and stuff. But when you do that, you will get negative 4 over 3 as an answer. Okay. So there's that. Now, on these problems, I'm not gonna show all this work doing it. Well, I'll tell you what, I'll do it on this one, but then I'm not going to do it on any of the other ones. So I've got negative 1/3 minus 3 minus, now this is negative 2, right? So I've got a negative and a negative, negative 2, which is going to be plus 2. And then you would get a common denominator, which would be 3. So that's 1. Was that 9 and 6? And so that's going to be, let's see, negative 1 minus 9 is negative 10, plus 6 is negative 4 over 3. Okay, so there you go. Now, I'm not going to show this anymore. You should be able to do that. If not, punch it in your calculator. All right, so here we have the integral. That's a 0 there. We've got 5x times x squared plus 1 squared. Now, if you remember from that video, from the video on indefinite integrals, we integrated stuff like this, okay? And keep in mind, we're doing the same thing that we did on indefinite integrals. It's just now we've got this extra step. See, I mean, we did this to get to this point. We integrated it. We did that with the indefinite integrals. And now with definite integrals, you got to do the extra step of evaluating it. Okay, but everything's the same as before. All right, so this one, if you remember, we're going to do U-substitution. Okay, now remember with U-substitution, if you have parentheses, look inside the parentheses. What's the derivative of inside the parentheses here? It's 2x. Well, does that match this out here? No. The derivative of this is 2x. Here we've got 5x. The x's match, but the coefficients don't. The numbers don't match. So what I like to do, if the derivative of this, if the numbers don't match, I like to take that number, so that 5, and I just pull that out. Okay. Remember, you can pull a number out. You can't pull a variable out, but you can pull a number out of the integral. And so let's do our U substitution. So I've got U is equal to x squared plus 1. And so du is equal to 2x dx. All right. So this, remember, is going to be replaced with u. And look at this. Here I have x dx. See, I've got x dx. What am I missing? I'm missing the 2. Okay, so now you can see I've got 2x dx, which matches that. But remember, since I multiplied by 2, then that means I have to come out here and divide by 2. Okay, all right, so this is going to give me 5/2 integral, and the x squared plus 1, that's going to be replaced with u, so that's u squared. And then the 2x dx, see, the 2x dx is going to be replaced with du. And now I can use the power rule. And that is going to go from 1 to 2. All right. Now, you're probably thinking, what just happened? Well, let's talk about that. What happened? Because you probably notice, hey, you changed the limits on the integral. All right. So let me show you what happened. So the original problem is in terms of x, and the value in these limits here on the integral, those are x values. Okay, these numbers here represent numbers we're going to plug in for x. But what happened? Well, we changed from x to u. We changed our variable from x to u. So now I've got to make my limits in terms of u. Okay, so how did I do that? Well, let's look at this. U is equal to 0 squared plus 1. So I took the 0, you see that, and I plugged it in here to get what u is. And so that's equal to 1. And then I have to take the upper limit, 1 squared plus 1, which is 2. So basically what I did here, this is equal to 1 squared plus 1, and this one is the 0 squared plus 1. You have to take your limits, plug it in here to get the values of u. Now, do you have to change your limits? No, you don't. And I'm going to show you in a minute how to do that, not changing your limits. But let me say this. It's easier, I think it's easier to go ahead and change the limits rather than not. And I'm going to show you, we're going to do this problem again where we don't change the limits, and I think this is going to help you understand more of what's going on. All right, so let's integrate. So we got 5/2, and so we've got u cubed, right? Add 1, multiply by the reciprocal of the new exponent, and then that's from 1 to 2. And so this is going to give me 5/6 u cubed from 1 to 2. Okay. All right. So this is where it's going to come in handy of leaving that 5/6. So that's 5/6, and now we've got what? 2 cubed minus 1 cubed, and that is going to be 5/6 times, that's 8 minus 1 is 7. And so that is going to give us 35/6. And there's your answer. Okay, so let's work this problem again. So let's pick up right here, and let's go from this step to this step. So I've got 5/2. Now remember, we're not going to change the limits. So instead of having the 1, 2 where I change the limits, I'm going to leave the limits at 0, 1. Okay. All right. And so that's going to be u squared du. And so that's going to be 5/2 u cubed 1/3 0 to 1. And so that's going to be 5/6. Now remember, I did not change my limits. So that means I have to take this and plug it back in for u, because I'm keeping my limits as x values. And so that's going to be x squared plus 1 cubed from 0 to 1. Okay, you see that? So now let's evaluate. So that's going to give me 5/6 times, now let's plug the 1 in, so that's 1 squared plus 1 cubed minus 0 squared plus 1 cubed. Okay, and I mean, you're going to get the same thing. So that's going to be 5/6 times 2 cubed. 1 squared plus 1 is 2. Whoop, let me do this. And then minus, that's 1 cubed. And you can see we're going to get 35/6 again. Now, look at this. You see what all we had to do here? We had to plug the x squared plus 1 back in for u, and then, you know, do all this arithmetic here. But look at this, and let me show you this. You see this part right here after we simplified? Look, that's the exact same thing right here. You see that? And then let me show you this. I wish this was down a little more, but anyway, look at this part, this 1 squared plus 1 and this 0 squared plus 1. You see that? Look, that's right here. See, you're going to have to do that eventually. To me, it's just easier to go ahead and change the limits rather than do this. Okay, so hopefully that helps you see about the, you know, changing the limits. Do you have to do it? No, but I think it makes it a lot easier. I mean, doesn't this right here, or actually just doesn't this part here look much easier and cleaner than doing this to get to that step? You see that? See, instead of doing it here, we're just doing it up here. Okay, so I wanted to spend a little time going over that. All right, let's look at the next one. All right, we've got us another U-substitution. So we're going to let what? We're going to let u equal 1 minus 3x squared. And so du is equal to negative 6x dx. So look at this. There's the x dx, the x dx. I'm missing a negative 6. So I'll multiply by negative 6. So that means I have to come out here and multiply by negative 1/6, or divide by negative 6, however you want to look at it. All right. So now let's make our substitutions. So I've got negative 1/6, and that's going to be what? U to the 1/3. I'm going to put the u into here, and then the negative 6x dx, negative 6x dx, I'm going to replace that with du. And then what are we going to do? We're going to change our limits. Okay. So I get u is equal to 1 minus 3 times negative 1 squared. Take the negative 1, plug it into here, and that is going to give me negative 2. And then I've got u is equal to 1 minus 3 times 3 squared. That is, what is that? Is that negative 8? I believe so. I'll double check, make sure I didn't mess up. And yes, I messed up. This should be negative 26. All right. I think I wrote it as 1 minus, I was thinking as 1 minus 9 in my head because of that. Wasn't paying attention to that squared. All right. Now, this next step that I'm going to do, you don't have to do it. I like to do it on problems, but have you noticed that when we're doing the definite integrals, that when we have our limits here, the lower limit's on bottom, the upper limit's on top. Okay, that's not the case here. See how the lower's on top and the upper's on bottom? Let's switch those. Okay, so that's going to give us 1/6 negative 26 to negative 2 u to the 1/3 du. So the reason I like to do that is it's more of what we're used to, having the larger number on top, smaller number on bottom. Okay, so you won't get messed up when you start evaluating this thing. Okay, you know, when you start evaluating it, you might accidentally put the larger number in and then the smaller number in. You know, if you have it like this, you might plug the negative 2 in first and then the negative 26. That's gonna give you the wrong answer. So what I like to do is just keep the smaller one on bottom, the larger one on top. Now, whenever you do that, whenever you switch these limits, it changes the sign in front of the integral. So notice it changes from a negative to a positive. And that's the other reason I like to do it is, I mean, and no, it's not that big of a deal, but it does get rid of the negative. Okay, I know it's not that big of a deal, but how many times have you forgot to bring a negative sign with you? I know I've done it plenty of times. Okay, all right. So now that's going to give us 1/6, and that's going to be u to the 4/3. Add 1 to the exponent, multiply by the reciprocal of the new exponent, and that is from negative 26 to negative 2. And so that's going to be, let's see, that cancels, that's 2, so that's going to be what, 1/8 u to the 4/3 from negative 26 to negative 2. All right. Now, that's going to give us 1/8 times, and that's going to be negative 2 to the 4/3 minus negative 26 to the 4/3. And look, that one right there, you just plug that into the calculator, and you're going to get negative 9.313. All right, so I mean, you think about it, that problem was not any more difficult than the ones we've done previously. It's just a little nastier having to evaluate this, but you got a calculator for it, so you know, just punch it into your calculator. All right, so let's look at this one. Oh, we got decimals as our limit, but that's no big deal. So for this one, it's going to be another U-substitution. Do I have something in parentheses raised to a power? Absolutely. Let's write it like that. So that's 0.1 to 2.7, and that's going to, and this dx up here, I mean, you can leave it like that. I typically just write the dx out to the side, but I guess since they wrote it like that, we can do that. Remember, square root is a 1/2 power. So I'm going to let u equal 4x plus 1. And so du is 4 dx. So notice, I've got the dx, I'm missing the 4. So I'm going to multiply by 4, come out here and multiply by 1/4. And so let's make our substitution. And so that's going to be, the 4 dx is going to be replaced with du, and then the 4x plus 1 is going to be replaced with u. And what do we have to do now? We have to change our limits. So I've got u equals 4 times 0.1 plus 1, and u equals 4 times 2.7 plus 1. And I will have to punch that into my calculator to get that. So this is going to be 1.4. And this is going to be 11.8. So that's 11.8 to 1.4. All right. And so we integrate this, so 1.4 to 11.8, and I'm going to have to write this as u to the negative 1/2 du. We're going to just move that up. Because remember, we need a variable raised to a power, so we can use that power rule. And so this is going to be u to the positive 1/2, right? Negative 1, negative 1/2. Plus 1 is positive 1/2, multiply by the reciprocal of the new exponent, and then that's from 1.4 to 11.8. And so this is 2 times, that's 11.8 to the 1/2, but how about we just put it as square root minus the square root of 1.4. It's just easier to hit the square root into your calculator. And that is going to give us 1.126. And there's your answer. All right, so we've got 2 more problems to work. So if you're still watching, keep watching. Don't stop the video. You're going to learn a lot of stuff in this one. All right, so let's look at this one. So remember what I said, if you have parentheses, if you have something in parentheses raised to a power, just look in there real quick, see what the derivative is, and see if that derivative is out here somewhere. So what's the derivative of this? And to do that, let's just go ahead and set u equal to this, and just check out what the derivative is, see if it's going to work. So du is 2x plus 2 times dx. All right, so of course there's the dx, but I don't have 2x plus 2, do I? But let's look at this. What if I factor a 2 out? You see that? Factor a 2 out of here. Well, look at that. Now, the x plus 1 dx, that matches. I'm just missing the 2. So I'm going to multiply by 2, so that means I come out here and multiply by 1/2. Okay? And so now the 2 times x plus 1 dx, I can replace that with du. So this is going to give us 1/2, and that's going to be 1, or well, we can put 1, we can put du. Let's just put the du over u cubed. So the u I'm putting in there. Now what do we need to do? Now we need to change our limits. So u is equal to, let's see, 0 squared plus 2 times 0 plus 2, which is 2. And u is equal to 4 squared plus 2 times 4 plus 2. What is that? 16 and 8 is 24. Is that 26? So that's 2 to 26. I believe that's right, but as usual, I'm going to check it. 4 squared plus 8 plus 2. Yep, 26. Just like to double check myself because it's easy to make stupid, careless mistakes. And then if I do, I get a bunch of comments on it. So, all right. So this is going to be 2 to 26. And that's going to be u to the negative 3 du. And so let's integrate. So that's 1/2. And that's going to be u, add 1. So that's negative 2. Multiply by the reciprocal of your new exponent. And that's from 2 to 26. And so that's going to give us negative 1/4 times, now let's take this u to the negative 2 and write it as 1 over u squared, 2 to 26. And so this is 1/4 times 1 over 26 squared minus 1 over 2 squared. And, you know, this one you're going to have to punch it into your calculator, and you would get 21 over 338. And that would be your answer. Oh, and I did. And you know what I was just talking about? And look, I did it. Bringing that negative with you. There you go. There's a good example there's a good example of bringing that negative with you. Okay. See, I forgot. Just didn't pay attention to it. All right. So the last problem. That's kind of an application, I guess. I don't know. I mean, it is an application problem, but they give you the equation that you got to integrate. You don't have to figure it out. So, all right. So it says the rate of flow Q in cubic feet per second of water over a certain dam is found by evaluating the definite integral in the equation Q equals this. Find Q. Now, notice in this problem, our variable is y. Okay. See the dy, we're integrating with respect to y. And so let's just write the problem down, 0 to 1.25. And that's going to be 240. Now, I'll say this. That 240, what's the derivative of this under here? It's -1, right? That's not -1. So let's go ahead and bring that 240 out. And so that's going to be 0 to 1.25. And let's write this as 1.5 minus y to the 1/2 dy. Okay, so all we're doing, we're just writing it, you know, just setting it up like we're going to need it. All right, so I'm going to let u equal 1.5 minus y. And so du is negative dy. And so let's see what we've got. We've got dy. I'm missing the negative. So I need a negative. So that means I need to come out here and put a negative. Okay. A negative and a negative is a positive. So that's like being +1. I mean, and if you wanted to, I mean, you could divide by -1 instead of multiplying by -1. It's the same thing. Okay. All right. So let's make our substitution. So that's -240, and we've got u to the 1/2 du. And what do we need to do? We need to change our limits. So we've got u is equal to 1.5 minus 0, which is 1.5. And then we have u is 1.5 minus 1.25. And that is going to be, what is that, 0.25? All right. So remember what I talked about earlier, these limits here. See how the larger one's on bottom, the smaller one's on top? Let's switch them. Why are we switching them? Because it's just, I think it makes it just, you're less likely to make a careless mistake, I think. And what is it going to do? It's going to get rid of that negative out there. So you don't do what I did in the previous problem and forget to bring that negative with us. So we got 240. And that's going to be 0.25 to 1.5 u to the 1/2 du. And so this is 240, and that's going to be u to the 3/2, add 1 to the exponent, multiply by the reciprocal of the new exponent, and that's going to be from 0.25 to 1.5. And so let's see, that will, I believe that's going to reduce. So I think this is going to be 160, this right here, and that's u to the 3 halves from 0.25 to 1.5. So that's going to be 160 times 1.5 to the 3 halves minus 0.25 to the 3 halves. And what do we get when we punch that into our calculator? We get about 274 cubic feet per second. Okay. Now I just got this answer out of the book. I don't know how much they rounded it or anything, but this is correct. I don't know how the book rounded it or if it is a decimal. Let me check real quick. Yeah, I mean, it's close enough. It actually comes out to 273.9387691, which just rounded to 274. But hey, look, that's the video. So if you notice, most of the problems we worked involved U-substitution. That's something that you're just going to have to know how to do. In this class, you're going to have to know how to do U-substitution. There's going to be a lot more of it later on in the course too. Okay, with trig functions, logarithms, exponents, all that good stuff. You're going to be doing some U-substitution. So just get used to doing it. But I hope the video helped. Check out my other videos. Give me a like, share, subscribe, and comment. Let me know what you think. Thanks for watching, and I'll see you in the next video. Later.